College Algebra, Module 7, Topic 7.1, Division of Polynomials. Objective 1, Division by a monomial. Remember that a monomial is a polynomial with exactly one term. To divide a polynomial by a monomial, divide each term of the polynomial by the monomial. For example, to divide 8x to the third plus 4x squared minus 12 by 4x, we probably want to write it as a fraction. Then we're going to divide each term in the polynomial by 4x. So that gives us 8x to the third over 4x plus 4x squared over 4x minus 12 over 4x. And then we're going to simplify each of those three pieces. Well, in the first piece, 8 divided by 4 is 2. X to the third divided by x would give us x squared. In the second piece, 4 divided by 4 is 1. X squared divided by x is just x. And then in the last piece, 12 divided by 4 is 3. Now notice that the x is in the denominator here, and there's not an x in the numerator to cancel, so we've got to leave the x in the denominator. So our answer would be 2x squared plus x minus 3 over x. Let's do another one. 2x to the fourth minus 3x squared plus 4x minus 8 divided by negative 4x squared. Well, to start with, we're going to divide each piece in the polynomial by the denominator negative 4x squared. So now we're going to divide each piece of the problem, or simplify each fraction. So the first piece, 2 divided by negative 4, won't divide, but we could simplify. 2 goes into 2 once, 2 goes into 4 twice. And then we're going to simplify our powers of x's. So we've got x to the fourth divided by x to the second, which would give us x to the second. So we end up with x to the second over 2, but a positive over a negative is going to give us a negative fraction. Second piece, a minus here and a negative here is going to make this plus. 3 divided by 4 we can't do. We can't simplify that, so we're going to leave it 3 over 4. And in this case, the x squared divided by x squared cancels, so there is no x. The next piece, we've got 4 divided by negative 4, which is a negative 1, so I'm going to call that minus 1. We've got x divided by x squared, which gives us x in the denominator, so that fraction will be 1 over x. And then the last piece, again, we've got minus a negative, which is plus a positive. 8 divided by 4 is 2. Notice again we've got an x squared in the denominator. There's not an x in the numerator to cancel with, so we're going to leave our x squared in the denominator. So our answer would be negative x squared over 2 plus 3 over 4 minus 1 over x plus 2 over x squared. Objective 2 is division by a binomial. To divide a polynomial by a binomial, we can use long division of polynomials. Before we start the long division, let's just go back and practice for a minute. Let's say we've got 3 into 567. We start out, we divide first terms. 3 goes into 5 one time. Then we multiply. 1 times 3 is 3. Then we subtract. 5 minus 3 is 2. And then we bring down the 6. Then we do it again. Divide first term, so 3 goes into 26 8 times. Multiply. 8 times 3 is 24. Subtract, we get 2. And then we bring down the next term, which is 7. Then we divide again. 3 goes into 27 9 times. 9 times 3 is 27. Subtract, which gives us a balance of 0. So our answer is 189. Well, when we do our long division of polynomials, we're going to do the same steps. We're going to divide first terms, we're going to multiply, we're going to subtract, and we're going to bring down. Okay, so when we start to divide here, so we're going to set this up x plus 3 dividing into 2x to the third plus 7x to the second. Notice there's no x term, so what we're going to do is we're going to add in a plus 0x placeholder minus 5. So now we're going to start out, we're going to divide first terms. So our first terms would be 2x to the third divided by x. This first term and this first term, which would give us 2x squared. So the 2x squared is going to go at the top. Now we're going to multiply, but we're going to multiply the number up at the front, the 2x squared, by the whole divisor x plus 3. So 2x squared times x would be 2x to the third. 2x squared times 3 would be 6x squared. Then we're going to subtract. But remember, to subtract polynomials, you're going to change all the signs of the polynomial being subtracted. So this is going to become a negative 2x to the third, and this is going to become a negative 6x squared. So when we subtract 2x to the third minus 2x to the third, that cancels and leaves us 0. Okay, that's what you want to happen. If those first terms don't cancel, then go back and pick a new first term. So when we subtract, 7x squared minus 6x squared is 1x squared. And then we bring down the next term of plus 0x. So that's our fourth step, is bring down the next term. Now we're going to start over again. Divide first terms. Well, this time our first terms are x squared divided by x. Well, x squared divided by x just gives us x, so we're going to put a plus x at the top. Then we're going to multiply. X times x is x squared. X times 3 is 3x. Then we're going to subtract. That goes to a minus. That goes to a minus. So we've got 0x minus 3x is negative 3x. And then we're going to bring down the next piece, minus 5. Then we're going to do it again. Divide first terms. This time our first terms would be negative 3x divided by 3. Negative 3x divided by x, which would give us negative 3. So our negative 3 goes up at the top. Then we multiply the whole divisor by negative 3. We get negative 3x minus 3 times 3 is 9. Subtract, which means change the sign, so that's going to a plus and that's going to a plus, and we get a remainder of 4. Now in polynomials, what we do is we take the remainder and we put it over the divisor and we add it back onto our answer. So our answer for this division problem would be 2x squared plus x minus 3 plus 4 over x plus 3. Objective 3, synthetic division. Synthetic division is a shortcut method to divide a polynomial by a binomial of the form x minus k. In synthetic division, the numbers in the third row are the coefficients of the quotient in descending powers. If the remainder is 0, then the binomial x minus k is a factor of the original function f of x. So let's take the same division problem that we had a minute ago and let's do it using synthetic division. Well, in synthetic division, you take your binomial x plus 3. When you do synthetic, it's by the 0 of that binomial, which means what makes x plus 3 equal 0? Well, that would be negative 3. So when you do synthetic division, you do it by negative 3. Then you take your coefficients of your polynomial that you're dividing into. Well, we start with the highest power of 2. Then there's 7x squareds. Again, notice there's no x's, so we have to put our 0 in there. And then this is our constant term. I'm just going to make a note here. This first term is x to the third, so we know we've got an x squared, an x, and a no x term. Well, in synthetic division, you always drop this first term down, straight down. Then you multiply -3 times 2, and you put the answer right here, which would be -6. Then you combine that column. 7 plus a -6 is 1. Then you multiply again. -3 times 1 is -3. Then you combine that column. 0 minus 3, or 0 plus a -3, is -3. Then you multiply again. -3 times 3 is +9. -5 plus 9 is 4. Now notice our quotient is always going to be 1 power less than what we started with. So that first term becomes 2x to the second plus 1x minus 3 plus, then the remainder is 4 over the divisor. Now notice this is exactly the answer we got doing it long division, but it's a lot shorter. Let's do another one. X to the fourth minus 3x to the third minus x plus 3 divided by x minus 3. Well, remember, synthetic division, if you're dividing by x minus 3, then you do synthetic division by +3. It's always the opposite sign of that last number. So a 3 goes on the outside. Now when we set up our problem, we start with the highest power. So that's 1. Again, I'm going to note that the highest power is x to the fourth. So then we've got our x to the third column. Notice we don't have an x squared column, so we're going to fill that in with 0. Our x column would be -1. Our no x column would be 3. So synthetic division. Drop the first term. Then you start multiplying and combining. 3 times 1 is 3. -3 plus 3 is 0. 3 times 0 is 0. 0 plus 0 is 0. 3 times 0 is 0. -1 and 0 is -1. 3 times -1 is -3. 3 and -3 is 0. That last term is your remainder, and that's what we were saying. If the remainder is 0, that means x minus 3 divides evenly into that polynomial, which means x minus 3 is a factor of x to the fourth minus 3x to the third minus x plus 3. Now because this one says divide, we need to give our quotient. Well, we take our coefficients and we drop a power, so that would be 1x to the third plus 0x to the second plus 0x minus 1, and there's no remainder. So really we could just call this problem x to the third minus 1. Now to check it, you could take your answer times your divisor, and you had better get what you started with. Okay, so just a quick check, we'd have x minus 3 times x to the third minus 1. This is a binomial times a binomial, so we would FOIL it out. First two would give us x to the fourth. Outer two would give us minus 1x. Inner two gives us minus 3x to the third. And the last two gives us plus 3. Arranging our answer in descending order, we get x to the fourth minus 3x to the third minus x plus 3, which is what we started with. So that says that it checks. Let's do another one. 10x to the fourth plus 7x to the third minus 27x squared plus 2x plus 8 divided by x plus 4. Well, again, for synthetic division, if you're dividing by x plus 4, then you do synthetic division by a -4. Bring down your coefficients. Start with your highest power. So there's our x to the fourth term. So there's 10, 7x to the thirds, -27x squareds, 2x's, and 8 no x's. So synthetic division. Drop your first term. multiply. Negative 4 times 10 is negative 40. 7 and negative 40 is negative 33. 4 times negative 33 is positive 132. So negative 27 plus 132 would be 105. Negative 4 times 105 would be negative 420. Plus 2 would be negative 418. 418, negative 4 times negative 418 would be positive 1,672. Plus 8 would be 1,680. It's a big remainder. So when we divide that, we would get, for an answer, 10x to the third minus 33x to the second plus 105x minus 418 plus 1,680 divided by x plus 4. So that would be our answer. Objective 4 is the remainder theorem. The remainder theorem says if a polynomial f of x is divided by x minus k, then the remainder is f of k. If f of k is equal to 0, then x minus k is a factor of f of x. Our example says, use the remainder theorem to find the remainder when 2x to the third minus x squared minus 4x plus 1 is divided by x plus 2. Well, what the remainder theorem says is when you divide this polynomial by x plus 2, the remainder is the same as what you would get when you do f of negative 2. So that says go into our function everywhere we had an x, plug in negative 2. So that would be 2 times negative 2 to the third minus negative 2 squared minus 4 times negative 2 plus 1. So that would be 2 times negative 8 minus negative 2 squared is 4 minus 4 times negative 2 would be a positive 8 plus 1. So we get negative 16 minus 4 plus 8 plus 1, which gives us negative 20 plus 8 plus 1, which is negative 12 plus 1. So our final remainder answer would be negative 11. If we did it synthetic division by negative 2, and we've got 2 in our x to the third, negative 1 in our x squared, negative 4 in our x, positive 1, and did synthetic, negative 2 times 2 would be negative 4, which gives us negative 5. Negative 2 times negative 5 is positive 10. Negative 4 plus 10 would be 6. Negative 2 times 6 would be negative 12. And 1 plus a negative 12 would be negative 11. That's what the remainder theorem says. It says plugging in that same number is the same as doing synthetic division and getting a remainder. And again, what we're going to be interested in is whenever the remainder is 0, then x minus k is a factor of the original function. Let's do another example. Use the remainder theorem to find the remainder when 5x squared minus 3x plus 1 is divided by x minus 1. Well, the remainder theorem says if we're dividing by x minus 1, then we're going to do f of 1, which means we're going to go into our function everywhere there was an x, we're going to plug in 1. Which would give us 5 times 1 minus 3 plus 1, which gives us 5 minus 3 plus 1, which is 2 plus 1, which is 3. I always still think it's a good idea to check that real quick. If we did synthetic, it shouldn't take long. Put our numbers in descending order, drop your first term, multiply 1 times 5 is 5, combine those two numbers, negative 3 and 5 is 2. 2 times 1 is 2, 1 plus 2 is 3. That remainder is the same thing as what we would get if we did f of 1. You are now ready to do the homework for topic 7.1 in my math lab. Let us know if you've got any questions.